thanks for coming to another workshop. This is our Intro to Java workshop. We have a great presenter for you today. William Swinny, better known as Swinny, is here with us, and he'll be teaching us the basics of the programming language Java in under an hour. So you can ask clarifying questions during, but we ask that any of your big questions that you hold to the end, because we will have 15 minutes, and you can ask me anything you want. Swinny earned his bachelor's degree in computer science and now works professionally as a software engineer. His specific areas of interest and expertise are cloud-native technologies, graphics programming, and spaces. So everybody in chat, if you could get some laugh emojis and give a warm welcome to Swinny.
Awesome. Well, hey guys, I'm Swinny. Welcome. This will probably be the fastest Intro to Java workshop you'll ever take. So I promise if you hold off on questions, I'll try to get to all of them at the end. Just so you don't try to rush through and also keep up with me while I'm typing. I've made all the code available to you over on GitHub. So after the presentation, if you want to go and download it, feel free to do that. We're just going to basically write the same thing that's already over there. But that way I can write it in front of you and kind of explain what's going on as we go. If you want to follow along, go for it. But I can't promise that I won't go a little bit faster just because we only have a short amount of time. So we'll go ahead and get started. If you have Eclipse open, I'm just going to start by creating a new Java project. I just start blank, and then that way you guys can see kind of every step of the way what we're going to do. So if you're going to create a new Java project, basically if you're working with like basic Java stuff and you don't want any kind of fancy stuff, all you have to do is give it a name and you should be good to go. So we can name this something like Intro to Java, and we should be good to go. So I can hit next. If you're working with like more advanced stuff, you can create like additional source folders and whatever else. You can add like some libraries. So if you guys like have like dependency jars or whatever you're trying to pull in, this would be the place where you can do that pretty easily. But we'll just go ahead and hit finish. If you're using Java 16, it's going to ask you to create like some module info and stuff like that. We don't really care about that for this demonstration, so we're just going to hit don't create, and we'll keep moving. All right, so we've got our blank source folder here. This is where all of our source code is going to live in a Java project. And we're going to start off by creating a couple of packages. So in Java, packages are where code lives. It's kind of like folders to keep everything organized. And in fact, under the hood, if you go explore your project, you'll realize that all the dot separators that we're going to use actually create independent folders by themselves. So it's pretty standard in Java. If you right click, you go new package, but it's pretty standard to name things kind of like if you think of it like a backwards like domain. So I'm going to start off with com.utsa, and then you can start with like an event name or a project name or whatever it is. I'm going to give mine a CodeQuantum. You don't have to follow along with that. You can name this whatever you want here if you have like your own domain or whatever's going on. This isn't like absolutely essential, but this is just going to help our code live in its independent little folders, so we can keep everything organized. So once I hit finish, you'll notice I've got a little like box over here. Boxes are packages. White ones just mean they're empty, like tan ones or whatever mean there's stuff inside of them. So I can right click here and we'll create a new class. So a class in Java is kind of just a file that represents kind of a structure where code is going to live inside of it. We'll talk more about like the intricacies of classes and different stuff like that later on. But for now, we're going to create what's going to be called our main class, which is where our public static void main method lives. That's where everything's going to kind of kick it off. So if you're familiar with C, that would be similar to like int main, or other programming languages typically use main as a construct for where the entry point of the program is. So I'm going to name this, and it's going to kind of give away what we're going to do. But we're going to name this CodeQuantum Bank Game. And we're going to create like a little bank today. And I was like, what's more boring than a banking application? We got to have something to make this exciting. So instead of just like a little menu where you enter and deposit and withdraw money from a banking account, because that's kind of boring and everybody's done that a million times, I thought it'd be fun to like create a little banking simulation that allows you to like enter some starting things, and then it tries to like simulate as basic as possible like a year of what might happen. And it gives us a good excuse to go through some like control flows and stuff like that in the programming language. So I'm going to check this box here. This is just going to give me the public static void main by default. If you don't check this box, like let's say you forgot and you just hit finish, right? You can just write it in here. So you can write in public static void main, and then it takes a string array, and you can name this whatever you want. When I was like earlier in Java, I used to name it beans because I thought that was funny, but we'll keep it as args just so people don't get confused. All right, and this is what we're going to leave here for now. This is just kind of a entry point for our program. So basically, like the code will start here when our program actually executes, and you'll kind of see that later on. All right, so for now, let's get started creating like our actual first class. If you're following along with the GitHub code, you may have questions as to like why I'm doing certain things, or like you're like, oh, he forgot that thing. I didn't forget it, I promise. There's like a flow here that I'm gonna try to get y'all through. So just stick with me here. So I'm gonna right click on this package, and we're gonna create a child package underneath it, and I'll show my disgruntledness with the Eclipse editor here in a second. But we're going to put a .account on the end of this guy, and you'll see that Eclipse kind of puts it next to this guy instead of like underneath it, like so I can collapse this one and this one's still next to it. This is technically a child package of this guy because they have the same root, but Eclipse for whatever reason decided that that's not how it's going to display it. So that's fine, but just so you guys understand that that's kind of what's going on here. All right, so we're going to create our new class. We're going to call this the account class, right? And this is going to represent kind of like a bank account and all the basic operations you may want with your bank account, and you know, kind of like very basic normal things you're going to do. We're not going to go like super in depth with it or anything like that. In fact, you'll see that I kind of originally housed some things in here that I was like, oh, we're totally going to use this or totally going to use that. It's going to be so cool, right? And we really don't end up using them all that much. But it's a good demonstration of kind of how to do it. So a class is sort of basically it's an encapsulation of everything inside of it, and this class represents kind of one entity or one object within a program. So you don't want to have like, for instance, you'll see like, and especially when I started out programming, like you toss everything in what you call like your main class or whatever. Like this guy, which has public static void main, like you'd end up with like, you know, like 3,000 lines of code in here. That's a really bad idea because it makes things really hard to like read and diagnose like later on. And then separation of like objects and entities is just a really good practice in programming in general. Just like you'll see later on, we kind of like will add on to this account class, and I'll show you kind of why that's actually a useful thing to kind of separate this out. So we'll create an account class. Typically in a class, you'll see variables at the top. These are what we call class members or class variables. These belong to the entire class. So any code that we write in the class can reference these guys at the top. And you have different modifiers, so you can make it public. If you made it public, I could see it anywhere in the entire code base. If you put no modifier on it, like occasionally you'll see people do this. Odds are, unless they've been programming Java for a very long time, they just forgot the modifier. If you've been programming Java for a very long time, you'll know that this means it's package protected. This means that anything inside of my package can see it. You can also add a protected flag to this, which means that both I can see it and any children that inherit from me can see it. And we'll talk about that in a minute. And then I can add a private modifier to it, which is what we're going to do. And private means only this class can see what's going on there. So we're going to keep this as private float balance. Balance is just going to kind of serve as our bank account balance. I added an interest rate to this. You'll see throughout the program we don't end up using it, but it's kind of a good excuse to just have a second variable, because usually in bank accounts you have some sort of interest rate. So we can add an interest rate here. So usually with these two variables, right, we want ways to be able to get them. So they're private, right? But we want to be able to see them outside of this class. So usually this is what we call data encapsulation, right? These variables belong to this object. And we don't want necessarily other objects just to be like, oh, I'm just going to like edit the balance really quick, right? Without us knowing. So we provide them what we call getter and setter methods. And these are kind of like ways in and out of the class that we control and have access to. And Eclipse will actually generate these for us, which helps a lot. But we're, in this case, going to write our own, just because it's going to be a little bit easier to start out with and show you guys kind of how all of this works. I realize I haven't talked too much about data types, but we'll get there. So actually, let's talk about them now really quick, just an intro. So Java has 8 basic data types. I could list them out here for you. We've started off with a float. You can think of float and double for now, especially if you're new to programming, as the same thing. We won't go into really the big differences there. Float means a floating point number. Double is basically also a decimal number. Double is technically larger than a float, and there's some weird shenanigans there that we won't worry about for now. But basically, your bank account balance is a float or a double, just because of the fact that you have like cents, like change on the end of it. So like, you don't only have like $320, you might have like $320 and like 43 cents. So we need some way to represent that 43 cents. And so we made this a float. You have integers are whole numbers. So that would be like $320. And let's say I did some sort of math equation that resulted in like $320.43, right? Basically that $320.43 would become $320. And so the integer by default just kind of like chops off the end. There's no sort of fancy rounding in Java. You just truncate it right at that decimal point, and that's what you get. There's a char or a char, however you want to say it. It's spelled C-H-A-R. There's like a million ways I've heard this pronounced. I say it char. That represents a single character. So you might say something like, oh, the character of the number 1 or the letter A or the letter F, right? That's what that represents. You also have a string. A string is technically not like a base data type in Java, but we're going to treat it like one today because we won't go into the difference in between all this stuff. But a string is basically like a string of characters. So where a char or a char is one character, a string is like the word beans, or whatever you want, right? It's multiple characters shoved together, and we'll see this used throughout our program as well. Those are kind of the big ones. Oh, there's one that I am forgetting that we'll use a lot is a Boolean, right? Or a bool if you're like used to like C and other like lower level languages. They're also called all kinds of other things in functional languages. But this is basically just true or false. And so we won't use any bool data types specifically, but we'll use conditions that evaluate to true or false. And we could assign those to bools and then use them in our what we call an if statement. And I'll show you that here in a bit. In fact, we'll write our first one in this class. All right, so let's get started kind of with our getters and setters here, and making sure that we can access all these all this private data inside this class. So we'll start off with making a getter to get our balance. So I could have Eclipse generate them for me if you're more experienced in this. I'm going to write them all out, and then we'll generate them in another class. And then that way I can show you how to do that. So we'll say get balance. And in Java, when you make a function, you'll always want a modifier. Same thing as the variables, public, private, protected, or package protected. we're going to stick with public because we want everybody to be able to get the balance of their bank account, right? This is not like private information. We just don't want them to directly have access to the variable here because then they could edit this without us knowing through our different getters and setters. So we're going to say get balance and we're going to return this dot balance. So this is a preference thing, and you'll see some people just write balance here instead of this dot balance. This dot balance is a way to be like extra explicit about what you're doing here. And it's kind of a stylistic thing. So you'll see me do this all the time just because that's how I write Java code, is to be like extra explicit and let people know exactly what I'm doing. So this refers to the current instance of this class. So like, let's say you made an instance of the account class, which means you would make like a version of this class, right? And actually use it as an account. Then you would have, access to all of these things. This refers to the current instance that you're using. So you might have like, let's say like usually one person doesn't have like only one account. They might have like a checking account and a savings account, right? If you have two accounts, this would refer to the current instance that you're trying to access. So if you're trying to access the checking account, this is the checking account's balance. If you're trying to access the savings account, it's the savings account balance. All right, so this is the way to get our balance. We'll go ahead and make another guy here. So another thing you want to be able to do with a bank account is deposit money. This you can think of as sort of a way to quote unquote set our balance, right? So this is what I mean by we don't want people to just set the balance, because you don't come into a bank account and just say like, oh, I have like $1 million, right? Like the bank doesn't let you do that. I wish they did. That would be really nice. But they don't. You have to actually like deposit money and accrue that money by adding it to your account bit by bit. And so this is what I mean by we're protecting those variables behind this. So we can kind of deposit money. Money is always going to be a float, right? And that's because it can always have like cents on the end. So you can have fractions of the whole dollar. And we can just call this amount right here. So this is the amount we're going to deposit. The operation when you deposit something into your bank account is you're going to take the balance, right, and add to it, right, the amount that you want to deposit, right? And there's really no like safety checks here other than like amount couldn't be negative. We're not really going to check for that. There's like technically a ton of safety checks you would want to do, but we're going to worry about like the very basics. So this plus equals here, like usually in a math equation, you might see it written like this, right? So you have like this dot balance equals this dot balance plus amount, right? And this is like the very verbose way of writing this. We can shorten this to just plus equals because we want to add the amount to the actual thing that we're setting it to again. So instead of saying the balance equals the balance plus the amount, we can just say the balance plus equals the amount, and this is the shorthand form of that. All right, so this is depositing money. You also want to be able to get money out of your bank account, right? Like your bank account is not like a prison for money. It would be good if you could have access to your own money. So we're going to create a public float. So this is our return type of our method. We're saying that we're going to get the float out of this since money is always a float in this case. And we'll come across other data types later on. But since we're dealing with money for now, we're basically only dealing with floats. So you want to withdraw money, right? And you may have an amount of money you want to withdraw, right? Okay, well, here's like a classic, and we'll just return 0 for now to make it happy. And you put this little F after it. So this is actually a good talking point right here. If you have a floating point number and you want to return like a hard-coded value, like let's say like if I withdraw, I can only withdraw the amount of like 32 cents, right? It's not happy with this because this thinks it's a double. To make it a floating point number, you just put the F afterward, and that says float. But for now, we'll just return 0.0F just so it stops yelling at us. And let's talk about this for a second. So when you withdraw money from your bank account, right, what happens if you have like $5 and you want to withdraw $10, right? Usually the bank, and like, let's say like on a bank that has overdraft protection, right, which is what we're going to write today, just like it's as a nice excuse to build in and throw an exception for the very first time. So let's say our bank has overdraft protection. We're not going to allow you to withdraw more than what exists in the account, right? So in that case, we would usually want to do in Java what's called throwing an exception. And an exception is a way to represent an error in a very clean format. So instead of printing an error and then just like killing the program straight out and just saying like, no, like force kill, die, right? Java has this nice way of throwing an exception, which basically just says, instead of continuing with the flow of logic that's in this function, I'm just going to go ahead and toss myself out. And I have an excuse for doing that, and this is the excuse, right? And so exceptions aren't bad. You can think of them as really good. In fact, you can create a lot of your own. And so that's what we're going to do right now. We're going to create an account overdraft exception. And that just says like, I withdrew too much money. So we're going to right click and create a new class right here. And we're going to say account overdraft exception. So we could come in here and like add all our interfaces and the super class and blah, 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 like use this to generate it all. I'm going to show you like the Java way to do it, because if you're using like other editors, like, JetBrains IDEs or other things like that, or I mean, you could use Notepad to write all your Java if you really wanted to, they won't have this nice fancy menu. So I'm going to hit finish and do this all by hand just to show you guys kind of how it works. So we have our exception here. It's really just a class at the end of the day, except this is our first chance to view inheritance. And actually, I'm going to skip the chance to talk about it now. We'll talk about it in a second because we're going to inherit our own class later on. Spoiler alert. So we're going to write here extends exception. So this may be possibly, one thing that I could say about inheritance right now is if you inherit a class, it's extends. If you've done or looked up some Java and you don't know what you're looking at and you see the word extends, that means I'm inheriting from a class. If you see the word implements, right, that's a different thing altogether. So it's a is a versus has a relationship is what we call it in like the academic terminology, right? So inheritance is an is a relationship and composition is a has a relationship. So in this case, you can think of this as inheritance because the account overdraft exception is an exception, right? If I use composition, like it doesn't make much sense to say the account overdraft exception has an exception, right? Like that's not really how it works, right? But it makes a lot of sense to say it is an exception. So in this case, like inheritance is the appropriate thing. Things to note, like if you're coming from like a C background or whatnot, which most of you guys maybe have never coded or whatever, but if you are coming from a C background, you may have heard of what's called multiple inheritance, which means that I can inherit multiple things. Java is always about single inheritance, so it's only going to allow you to inherit from one class and prefers composition over inheritance because it will allow you to have many attributes but only be one thing. So that's a way to say you can only is a one class but has a many classes. Yeah, Zach says, can we make the font bigger? We can definitely make the font bigger. You can see I was playing with my font. So we'll edit this. We should be at, that's our block selection. We don't want this. We want this guy. Let's make it like size 22. All right, hopefully that's better. All right, so we're gonna write our first exception here. And like you may see this little warning here, there's a quick fix. It wants us to add what's called the default serial version ID. And I'm not going to explain what this is for now. If you're really curious, I'm going to say Google is your best friend. Google is probably better because there's a long explanation that goes into this, and I will probably confuse a ton of people if you aren't like pretty well versed in Java. So for now, what we are going to do is we're going to define a constructor, and a constructor is kind of an entry point into our class. So we make a new version of this class, right? What we're going to want to do is call the constructor. So if you make like, let's say like a new object, which we'll do here in a second, you can either call what we call the default constructor, which is just empty parentheses. So if you've coded before, you may say like, oh, I want a new, like, I don't know, a new Pokemon, and then you put like empty parentheses after it. That means that we're just going to call like the default constructor and there's nothing to really do. We're going to change our default constructor out for a constructor that takes a message, because we don't want to throw an exception without having a message associated with it. Because I know you all love when you're like playing your favorite game and it crashes and then doesn't tell you why. So this is why we add a message to these things. So the way we make a constructor is we just make it public. We can make constructors with different accessors. We won't really talk about why we want to do that or anything right now. But what you need to know for now is probably most of your constructors will be public. We're going to make the constructor the same name as the class. And that's basically our return type. And then it has no name. And so basically this is a method that has a public accessor, a return type of an account overdraft exception, which is this class, but no name associated with it. And that's what we call a constructor. You'll see here, this is a mimic of the default constructor. So this is what gets added by Java by default when you automatically run your program. But you can come in here and add additional arguments. So we're going to go ahead and use a string because, we want a representation of many words in our error message, not just like a single character. There are people who do that, or like they use like a number like, error like 74853, and then you have to go to Google and be like, what the heck is error 74853? And then there's like 58 comments on different errors. So instead, we're going to be really nice to the user and print them a message. And inside this message, we want to do something in here, right? So this is possibly the first time that we'll see, first and only time we'll see us do this. We're going to use the keyword super. And super is used to refer to my parent. So I'm account overdraft exception, but my parent is exception, right? Because I inherit from him, right? And so you can think of me as like a child of exception. So I'm a child of exception. I'm a type of exception, right? But my parent has all of like the stuff that we want to use up there. So I'm just going to kind of borrow from him. And I'm just going to put super dot parentheses. So I could do super dot and call like, you can see all this stuff that I can call in here. There's like a bunch of things. Instead, I'm just going to do super parentheses, and this allows us to call the constructor of our parent, because our parent already has a constructor that takes a message, and he does all the work for us magically, so we don't have to do anything. So we're going to borrow that from our parent here and just say, oh, hey, look, here's super message. So this is going to set the message at our parent level. That way we don't have to do a bunch of work. We're offloading onto them. All right. So we can go ahead and close this file for now because we're really not going to come back to it. But we are, however, going to come back to our withdraw method over here, and we're going to make sure that we can actually throw that exception that we created. So the way we do that is we first have to declare that this method is likely to throw something. So we can say throws account overdraft exception. So the way this works is this basically tells the person calling this method, hey, this will probably throw this if bad things happen. You should be aware of that, right? The next thing we want to do is come in here, right, and say, oh, hey, if our balance, right, because this is the reason we created this, is what happens if we try to withdraw too much money, right? So if our balance is less than the amount, right, that we're actually trying to get, right, then we want to go ahead and throw that account overdraft exception. And the way we can do that is we can just say throw, and then we can make a new object. So we'll say new account overdraft exception. And you'll remember that it takes a little message. So you'll notice that this is yelling at me because there is no default constructor. We've made the only constructor available to us one that takes a string. So I might actually go to the new line just so we can fit this all on one screen here. But I might say something like account attempted to withdraw like X amount. So in strings, we can use the plus sign to add together like multiple parts of one string. So I can say like account attempted to withdraw amount. And then maybe I'll go to the next line just so we can save some space here. We can say, but only has balance of, and then we can put this dot balance, right? And so this is a nice way to inform the user, like, hey, you attempted to withdraw money, but the amount you tried to withdraw is less than your balance here, or is more than your balance, sorry. So we can represent that in one way. We can say if the balance is less than the amount you're trying to withdraw, or if the amount you're trying to withdraw is more than the balance, right? And so either one works. I prefer this way. Either way, it doesn't matter to me. But we can come in here now and say, okay, if that if statement doesn't happen, and we can come down here. This is what we call an implied else. So you might see like newer programmers try something like this, where they put the else here and then put all the rest of the logic in here. An implied else just means like there's going to be no more control flow outside of this if else statement. So I can just use an implied else since this is an exit of the method. And so implied else just means I'm going to throw the rest of my logic down here. And so I'm going to say this dot balance minus equals. So just like we used the plus equals earlier to add to the balance, we're going to use the minus equals to take away from it. So we can say this dot balance minus equals amount. And then at the end of the day, I want to return to the user how much is now in their account. So I can return the balance left, right? And that might come in handy later. Like let's say I withdraw money and then I want to know how much is left. Instead of withdrawing and then calling get balance, this is a nice convenient way to say, hey, you withdrew this much. This is how much is left. All right, so a couple more operations that we may want to do is be able to like set and get the interest rate of our account, right? So the bank may want to set it and we may want to get it. This is where I'm going to show you how to auto do this with Eclipse, just because these are pretty straightforward methods. And we've written a few up here so we get the basic idea. If you come up here to the source menu, there's a source menu that you probably cannot see. But at the top, if I was using Windows, it would be nice. There's a source menu. We're going to hit generate getters and setters. This screen share really doesn't love me. That's okay. Basically, when you hit generate getters and setters, there's going to be a window that pops up with checkboxes for the different class level variables that you want to generate getters and setters for and where you want to put them in the code. So I'm just going to check the one that says interest rate and I'll hit generate, and then you guys can actually see it generate right here. All right, cool. So here's where it generated those methods. You can see that it's just named public float. We called it get interest rate. Just like up here, we did similar to get balance. It returns the interest rate. And this is what I was talking about earlier, where you can see my stylistic like this dot, right? So we can come in and add it if we really want to, or we can leave it alone. Here, it's using the this dot to differentiate between the input parameter and the class level member. And so you'll notice that we have a method here, public void set interest rate, right? So it's public, everybody can see it. We're not going to return anything. That's what void means. We're going to set our interest rate to a floating point number because money, and percentages aren't always whole digits either. And then we've got our interest rate here, but you'll notice that this is called interest rate up here and this is called interest rate right here. So the way to differentiate between the two is to put this dot in front of it and say, this is at the class level, this is the one right here. And you'll notice that most IDEs are pretty kind to you and they'll make them like different colors and all that kind of stuff so you can see what's going on. All right, so this is what represents an account, right? So basically now with our account, we've encapsulated this idea inside of an object where we have a balance, we have an interest rate, we can get our balance, we can deposit money, we can withdraw money, right? If we withdraw too much money, it's going to toss an error out at us. We also have an interest rate that we can use in the event that, like, let's say we gain some interest every 30 days. Now we have some way of representing that. So now what we can do is we can actually come up here and we can make this class abstract. So this abstract class means that, hey, this class is, it's fine, but it's sort of like a base class. So in the real world, we don't just have accounts, right? That would be great. I don't have to look at like, oh, there's like this kind of account, this kind of account, this kind of account. There's just one account. That would be so much easier, right? But instead we have like checking accounts and preferred checking accounts and savings accounts and like money market accounts and all these different types of accounts. So this is the basic idea of an account. And that's kind of what abstract says. Abstract says, hey, this is a class. It encapsulates this idea, right? But I'm not going to allow you to make one of these. Instead, you have to make your own kind of this thing and then instantiate that instead. So to represent that idea, we're going to make a checking account here. So I'm going to go ahead and make a new class. We're going to call it checking account. Right, and then we're going to use that inheritance we learned a little bit about earlier, where we're going to say extends account. And that extends account basically says, hey, a checking account is an account, guys. It's a type of account. And so you'll notice that even though this class is blank, because I am tied now to my parent, right? So I am an account. I get all of this functionality for free, which is great. So if you have like a base idea, like, like every Pokemon has like health, moves, all this kind of different stuff, right? So a Pokemon is like a base idea. And there's like, like 100 million jillion kinds of Pokemon, right? So all of those could be types of Pokemon, and that would be like a similar scenario here. All right, so our checking account for now, we're going to leave it blank, and we're going to talk a little bit. So we've talked a little bit about inheritance. We now have an example of inheritance. We're going to talk a little bit about composition, and then we're going to write our base class. So let's talk a little bit about composition. So in Java, composition is a has a relationship. So what does a checking account have that other things don't have, right? So things we may not want to include in the account base class are things like a debit card, right? So like a checking account has a debit card, but usually a savings account doesn't. So that would be more of like a has a relationship. And so the way we represent those in Java is with interfaces. So I'm going to go ahead and create a new interface. And I'm just going to call this guy debit card. All right, so our debit card interface here, an interface is not a class. Basically, it's a blank template in a way that you can write code once you like implement that template. So a debit card is like a templated idea where it's like, these are the operations if you have a debit card you may want to perform, right? But I'm not going to tell you how to do it. So an account tells you, here's the operations you may want to perform. Here's how they're going to work. A debit card will tell you, here's the operations you may want to perform. I don't know how they work. You tell me. And so we're just going to define a really simple method here called make charge. All right. And when you make a charge on a debit card, like typically there's like 1,000 parameters, but we'll just talk about 2 of them. Like you may have like an amount that you want to make the charge for and a vendor that made the charge, right? And these 2 things are all we need to make a charge, right? So let's say like this is our template. So to make a charge, we need an amount and a vendor. Now you notice there's like no code beneath this. Instead, I ended it with a semicolon here. And that just basically says, all right, cut it there, right? This is the template. This is what, a debit card we want it to do. So over here in our checking account, we've inherited from account, but maybe we want to implement because we are an account. So a checking account is an account, but also has a debit card. So if we write implements debit card here, okay, great. Look, now we've got our interface. And you'll notice this is red because remember how we didn't write any code underneath this method here? So this guy is like, whoa, there's a method over there and we don't know what to do with it. So you're going to have to add that method to this class and then actually write what we call an implementation for that method. So if we click on that little option that says like add unimplemented methods, it gives us this nice little method here that we can play around with. And basically when you make a charge to a debit card, right, it's pretty easy concept, right? You're just going to take that money out of your account, right? So you remember that when we withdraw money from an account, even if we do it via the card, right? If we withdraw too much, like if I have $5 and I go to like, Walgreens and I'm like, hey, I want to spend like, I don't know, I want to buy like the whole store or something like that and spend like $1 million, something ridiculous, right? Well, I don't have that much money in my account. So the bank is going to decline the charge, right? So we threw an exception if we try to withdraw too much. So we're just going to go ahead and make a try catch, right? And this try catch represents a structure that allows us to try something. And then if it doesn't work, like let's say there's an exception thrown or an error or something like that, then boom, we can catch it right away and go for it. So we're going to catch the account overdraft exception. And we can just name it E here. And so in here, what do we want to try? Well, we want to try withdrawing from the account the amount that we're gonna do. So I'm gonna use my parent here, right? Because my parent is the account. He brings all the functionality with him. So I'm gonna say super.withdraw, right? The amount that I want to withdraw, right? And then if there's an exception, which it's yelling at me because why now? Is it because I did not spell it right? Probably. All right. Instead of spending time to find the spelling error, we're just going to copy and paste. There it was. Okay. Great. So we're going to catch this account overdraft exception. And when we catch it, instead of blowing up the program or something like that, we're just going to kindly decline. So we're going to say we're going to print a statement, right? And system.out.print will print to a single line without a new line, and print line will print something and then make a new line after it. So we're going to use print line, and we're going to say card declined due to, I don't know, like card declined due to insufficient funds. Right? Okay, and we'll put like an exclamation point there. Whoa, crazy. All right, so our card got declined due to insufficient funds. And so basically now we have a debit card and we can make a charge. And even though the debit card doesn't tell us how we're going to make the charge, the checking account can. And it can say, this is how you make the charge. You're going to try to withdraw money from the account. And if you get an account overdraft exception, we're just going to print this nice little message and move on with our life. Right? Okay, great. So we've now seen all kind of different ways that we can handle different stuff. Let's actually go back to our main program now and write like a short little simulation of, how this might work, like a day in the life. If you're following along in GitHub, you'll notice that I'm missing several things. It's because we're a little short on time. So we're going to go ahead and keep this where it is. And then using those concepts on GitHub, you can go ahead and read through the rest of the code there. So over here in our main class, we're going to go ahead and create an object for a checking account. Right? And we'll just call this checking account. We'll also go ahead and create a random generator. And we'll also go ahead and create 3 variables to hold some information. So we're going to hold a daily salary. And we're going to hold 2 variables here that are integers because we want them to be whole numbers. And even though money is floats, I decided just to throw some ints in here just to get you guys accustomed to it. And we're going to make a min price in dollars and a max price in dollars. All right. And so up here, these are yelling at me because in Java, if you're using things, from another package, like this guy comes from a Java package, Java util, and this guy comes from our ComUTSA CodeQuantum account. In Eclipse on Windows, you can either hit Control-Shift-O or on Mac Command-Shift-O, and then we'll add the imports to the top here. All right. Let's start by going ahead and writing a couple of methods to easily make our simulation. And this is where we can talk a little bit about loops and the rest. So over here, I'm going to make a couple of methods. We're going to call one simulate year. And they're not going to return anything, and you'll see why in a bit. We're going to call one simulate weekday. And we're going to take a roll for this, and that's kind of like a roll of dice. And we're going to copy that and simulate the weekend at the same time. And so now we've got a couple of methods here to kind of figure out what's going on in our simulation. We'll also want to print what happened afterward. So we're going to print our end of year status. And we'll go ahead and tackle this one first because it's the easiest one at the bottom. So we're just going to go ahead and print out like you ended the year with, you know, this dot checking account dot get balance. So we can see a use of the get balance method here. And I'm going to hit enter so we don't run off the screen. And we can put another plus and just say like in your account. All right, cool. So now we've got kind of a version of this that says like you ended the year with, you know, X dollars in your account. We can even add a dollar sign to make it like super fancy. Bam. All right. So this is the kind of the easiest part of this. We'll talk about these here in a second. The first thing we want to be able to do though is get input from the user to be able to determine what is our daily salary and what do things cost in the world that we're in. And so what we want to do over here is use an object called scanner. Scanner is just kind of a basic object that gives us access to take command line input from a user. So no fancy GUIs, nothing like that. But we're going to make a new scanner here. And we're going to use the system.in as our way to get input. And that just says, hey, we're going to be getting input from the command line. All right, great. So then we're going to add a couple of print statements here. And I'll just copy this a couple times. All right, so we're going to need three things or three pieces of information. We need your daily salary. We'll put daily salary question mark. We'll also put, and actually let's make these prints and I'll show you why. Because when you enter your input and you hit enter, it will move to a new line. So it's just going to make it look nicer. So we're going to get our daily salary. We're going to get our min price, and we're going to get our max price. All right, great. So we need a place to store this information. So they'll all come in as strings because that's how the command line kind of interprets things. So we're going to say that we want our salary, and this is going to be scanner.nextLine. And this just kind of grabs the rest of the line as you input something. And I won't kind of be showing how to do like input validation and the rest. That you can do with like, you know, some simple if statements or stuff like that if you want to take care of it. But we've got our salary. We're also going to have our min price here and our max price. And so this allows us to get the next line until they hit the enter key. So if they type like, you know, like 384, you know, blah, 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 dot, and then they hit the enter key. That's what's going to be stored in salary. So ideally they type a number, and we won't be doing that kind of validation here. But ideally that's what happens. All right. And once they type a number, we want a way to kind of initialize this little simulation game here. So we're going to make a CodeQuantum bank game constructor. And it's going to take our salary. It's going to take our min price. And it's going to take our max price. And so then we'll edit all of these things as we get them. The most important part is to be able to pass them in. So we're going to go ahead and make a CodeQuantum bank game object here. We'll just call this game. And we'll move this to the next line, just kind of make it easier. So it takes three things. It takes our salary, our min price, and our max price. So these are strings, but we want them to become integers. And there's actually a really easy way to do that in Java. Java has a lot of convenience methods. And so we can use something called integer.parseInt. And parseInt will allow us to easily parse the integer that we want. And you can see Eclipse has already guessed that I want the salary. And we can even parse int for our min price and we can integer.parseInt for our max price here. And so ideally they enter 3 whole numbers of what their salary is. And this isn't going to actually be their daily salary. This is going to be their yearly salary. And we'll do a little calculation to make it their daily salary. So over here in our CodeQuantum bank game, let's go ahead and initialize this stuff. So we're going to need a new checking account. So this is going to be equal to new checking account. And even though we didn't put a constructor, remember that Java adds one by default. So we kind of have that there for us automatically. We're also going to need a new random number generator. So we're going to go ahead and make a new random object. And this is what we commonly refer to as the seed. If you guys are, into the gaming culture or whatnot, you'll know that seeds are the way that we generate random numbers kind of differently per execution. So by default, the seed is 0, but we can use a clever trick to get the current time in milliseconds of the time you ran the program and just kind of use that as the seed. That way it's really hard to guess what it's going to be at the exact time of execution. We can also set the daily salary now, and we're going to want to cast this to a float. So if something isn't already a floating point number and you want to make it one, you can pretty easily just cast it. And that's what this parentheses with the float inside of it means. I'm going to add another set of parentheses, and then we're going to say we want to do the salary for the year divided by 261.0. And this is the amount of working days in 1 year. And that's kind of key to our simulation here in a bit. Oops. All right, so we've kind of taken that integer that they gave us, divided it by 261, and then converted it to a floating point number. We're also going to set the min price dollars equal to the min price, and the max price dollars equal to the max price. All right, so we've got our simulation set up here. We can get user input. After we get our user input, we're going to want to go ahead and simulate the year. And you'll notice I don't have to add any additional arguments. We now just sort of have to fill out these methods as to what we want them to do. So in order to keep this short, we'll go ahead and kind of write an abbreviated version of this over here. So we're going to say, we're going to make a for loop. And a for loop is a way to loop through something with a counter. And so here's our loop, and inside of our what we call our loop body, which is these parentheses, we're going to go ahead and make our counter. And usually you'll see I as the variable for the counter. And so it starts out with an initialization of I equals 0. Then we can say loop until I is greater than 365. You'll notice I put less than. That's because it's sort of a check condition. So it's going to say, I is 0. Is I less than 365? Okay, keep going. Right, and the last part is what we call the increment or decrement operation. And this is where you modify I, so the loop will eventually end. So you can say I starts at 0, while I is less than 365, keep looping. Every time you finish looping, increment I by 1, and that's what that little plus means. So this is the same thing as I equals I plus 1, or I plus equals 1, and we can shorten that even further to I plus plus. All right, so now we're going to talk about a couple of other operators you may run into all of the time in Java, things like modulus, and we're going to talk a little bit more about if statements using ands and ors and stuff like that. And this is kind of my good excuse to toss these in. So we're going to first need to know what day of week it is. And so the reason we're looping 365 is because we're trying to simulate the year, which has 365 days. And so we're just going to kind of say I mod 7. All right, this modulus operator is the division remainder operator. So it says if you divide I by 7, what's the remainder of that division? So, normal division would just be a divide sign and you would get some sort of hideous decimal at the end. But instead, if we use the modulus operator, instead of the whole part, we get the fraction remainder at the end there as a whole number. And so how many times does I go in and what's left over? That's what we get in this day of week. And so this is a really clever way to say, if you divide what day we're on by 7, and then you kind of look at where that is in the year, it should be equal to the day of the week that we're on now. So this is kind of what day of the week is it. We then want to roll a dice, right? And we'll explain why in a second, but we can say this.random, which is our random number generator up top. And we can call the next int function here. And the next int is going to get the very next integer in the random seed. And we can give it a bound even. So this will generate numbers 0 through 99. And you'll see my bound is 100. And that's because it generates 0 through exclusive of this upper bound. So it's going to generate 0 through 99, which means it has a range of 100 numbers. And that's not by accident. We're going to use this to make kind of like a little random chance here. Then let's talk about some more if statement stuff here just to show you guys. So we can say if the day of the week, right? So let's say we want to know if it's a weekend, right? So the week starts on Sunday and ends on Saturday. Let's just say for this simulation, that's true, right? Maybe your week starts on Monday and ends on Sunday, however you want to do it. But for this simulation, we'll start on Sunday and end on Saturday. So if the day of the week is 0 or the day of the week is 6, right? Then it's going to be a Sunday or a Saturday. And that's through this remainder operation here. And so if you have a remainder of 0, that means we're at the very beginning of the week. If you have a remainder of 6, we're 1 day away from the end of the week. And this little two vertical pipes means that it's an OR operation. If I replace these with little AND symbols, that means it's an AND operation. So an OR operation means either of these are true and the code inside this if statement will happen. AND operation means if both of these have to be true for the code in this if statement to happen. So for this OR operation here, we're going to say if it's, a day of the week that's 0 or 6, we want to go ahead and simulate the weekend. And we're going to pass it our dice roll. And then otherwise, this is just going to be a weekday, right? So if it's not a weekend, that means it's a weekday. And we can say simulate weekday and pass it a roll here. We can really quickly finish this off by, making some really quick, adjustments in GitHub. There's a lot more code here to kind of show you some different items. But we might say on a weekday, if the roll is less than 5, which is like a 5% chance, that would be 0 to 4, maybe you make no money today. So we're just going to go ahead and return. But otherwise, maybe you make some money. So we'll deposit into your checking account the amount of money you made, and this will be your daily salary. So there we go. We gave you some money if you worked for the day. And then on the weekend, let's say, usually you're out shopping and the rest. So if your roll is less than like 70 or something like that, so that gives you like a 70% chance, right, to have this action happen. Maybe you're going to buy something today, right? And so, we have a min price and a max price. So let's go ahead and I'm going to show you how to make an amount here. So how much are they going to charge us? So we're going to get the next integer out of this random generator here. And we're going to say this dot max price dollars minus this dot min price dollars here. And then this will give us the upper bound, but then we're going to add the min price dollars back to it. And so we kind of reduce the upper bound by the amount of min price dollars because we're going to raise it by that min price dollars. So this is like, let's say if something costs between $5 and $10, right? And you want to generate a random number in between 5 and 10, your maximum that you're going to generate is between 0 and 4 to start with, and then you'll raise it by the number 5, and that'll bring you up somewhere in between $5 and $10. All right, so after we have our charge amount here, we can go ahead and, because this is a checking account, right, and usually you buy things by swiping your card, we can go ahead and say for your checking account, you're going to make a charge, right? And you're going to make a charge for that charge amount, right? And then, I don't know, maybe let's say you buy everything on Amazon. All right, great. So now we made a charge on Amazon. right? And so now with all of this code present, we can kind of run our little simulation by clicking the run button up here at the top. And we can enter our yearly salary. Let's say we make like, I don't know, $40,000 a year. And the minimum price of an item is like $10 and the maximum price is $100. And then we got some card decline due to insufficient funds. Oh, but after we simulated the entire year, we forgot to print our end of year status. So let's do this one more time, except this time we'll print the end of year status. So let's say this time we make like $100,000 and then the min price of an item is like $100 and the max price is like $200. Yay! So we ended up with $83,998.02 in our account after all of our transactions through the year. So this is kind of a fun way to learn Java and to have an intro to Java. It's a lot in an hour. Learning Java or learning enough about Java to be dangerous in an hour is a tall order for sure. There's a lot more of this code available on GitHub. Yeah, that's pretty much it. I think I can stay a little bit after if people have questions. I know I went right until my time, unfortunately. So you let me know if that's okay or if you have to kick me out.
Yeah, no, that is perfect. Yeah, so if you have any questions, go ahead. Now's the time to put them in chat. And while we're waiting for that to come through, I just want to say thank you so much, Swinny. Let's go ahead and give him a round of applause through the chat. If you can drop some emojis. Thanks for showing us Java. And I'll go ahead and give a little bit of announcement for what's coming next, and then we'll see if there's any questions. So what's coming next is we have a mini event going on right now, which is a Bob Ross painting. So the link is already in Discord for that. It's in the announcement channels. And also, if you want to use Java in your project and you want to use this as a baseline, we also have mentors that can help you out in the Contact a Mentor channel. So if you have any questions that maybe don't come up now, but come up later, you can feel free to ask them then. So it doesn't look like there's any questions in the chat. Yeah, I'm sure people will just go and, again, that code's on GitHub, so feel free to get it from there and then mess with it. But I don't think we have any further questions.
Awesome. Well, thank you guys. And I know that was super fast, so I think they'll have a recording available too. So feel free to watch it back if you missed a little part of it or some part was confusing.
Yes.
But thanks, guys.
All right. Yes, those recordings will be posted to Twitch and YouTube as soon as they're done processing. But thank you so much, Swinny. And we'll see everybody at Bob Ross Painting or our next workshop at 6 p.m.